Hi everybody. So the title of today's lesson is FTC Applications. And no, I'm not talking about how to get a job working for the Federal Trade Commission. I'm talking about the fundamental theorem of calculus. So, as I mentioned briefly, the FTC actually has two parts. The first part of the FTC says that the derivative of an integral is equal to the integrand. The second part of the FTC says that the integral of a derivative is equal to the difference between an antiderivative for that derivative evaluated at the two endpoints of the integral. So this is the FTC we use the most, and this is usually the one that we just call FTC. But just FYI, if anybody ever asks you to compute a derivative that looks like this, you also use the FTC. You just use a different part of the FTC. So now let me give you an example of an FTC application. So the example says that the price of pineapples, which is given by some function p of t, changes at a rate of p prime of t equals 5 over 1/2 t plus 3, the quantity squared. And it's asking me how much will the price change on the time interval from 0 to 10, where t is measured in days and p is measured in new Taiwan dollars per kilogram. So the basic idea here is that the change in price of pineapples on 0 to 10 is equal to the integral from 0 to 10 of p prime of t dt. That's what the FTC tells me, actually, because this statement is just the FTC. That integral is equal to the integral from 0 to 10 of 5 over half t plus 3, the quantity squared dt. Now, I'm just going to guess and check an antiderivative for that integrand. And I'm going to guess that an antiderivative would be g of t equals minus 10 over half t plus 3. And we'll just check that. G prime of t is equal to minus 10 over half t plus 3 to the power of 2 times minus 1, because I started with a minus 1 power, times the derivative of half t plus 3, which is equal to 10 over 2 times half t plus 3 quantity squared, which is equal to my integrand. So this antiderivative will work, and that tells me that my integral is g of 10 minus g of 0. And that, again, just follows directly from the FTC. So now if I compute g of 10, that's minus 10 over 1/2 times 10 plus 3. And if I compute g of 0, that's minus 10 over 1/2 times 0 plus 3. And if I crunch the numbers, the answer I arrive at is 25 over 12. So my final answer turns out to be approximately 2.08 new Taiwan dollars per kilogram. All right, so our next example is an extremely common type of application of the FTC, and this is called an initial value problem, or IVP for short. And so in this problem, we're given the second derivative of the height function of some projectile, and we're asked from that second derivative, plus some initial information about the position and velocity of the projectile, to compute the height function of the projectile exactly. So in this case, the first thing we want to do is use the fact that the first derivative is the integral of the second derivative. And the second derivative in this case is t minus 9.8 meters per second squared. So the most general antiderivative is t squared over 2 minus 9.8t plus c. And my problem tells me that h prime of 0 is 100. So I can use that information in order to find out what that constant c is. First, I'll find h prime of 0 based on the formula I found, and then I'll use the initial information, which is that h prime of 0 is equal to 100. So that tells me that 100 is equal to c. So now I have a better idea of what h prime is. So next I want to find h of t. So again, h of t is going to be the indefinite integral of h prime of t dt, which is t cubed over 6 minus 4.9 t squared plus 100t plus a constant. And again, I want to find what that constant is, so I use my initial information. So my initial information tells me that 2 is equal to h of 0, and the formula I just found tells me that h of 0 is just that constant c. So h of t is t cubed over 6 minus 4.9 t squared plus 100t plus 2. And that's my final answer. Okay, so the last problem I wanted to cover today involves farming beetles. So a beetle farmer determines that the rate of change of a population of beetles is f prime of t equals 20 e to the minus 0.1t over the quantity 1 plus e to the minus 0.1t squared. So the farmer starts with 100 beetles, and he wants to know how long until there's going to be 1,000 beetles. So basically, to solve this problem, we want to be solving the equation f of t equals 1,000. But in order to solve that equation, we need to know what f of t is. And fortunately, the FTC has something to tell us about the subject. Specifically, it says that f of t minus f of 0 is the integral from 0 to t of f prime of t dt. So we can rearrange that FTC statement into an expression that's going to give us our function f of t. And that is that f of t is equal to f of 0 plus the integral from 0 to t f prime of t dt. So from there, we'll plug in the information the problem gives us to get f of t is 100 plus the integral from 0 to t of this ugly integrand. And from previous problems involving logistic population growth models, we know that an antiderivative for this thing is 200 over the quantity 1 plus e to the minus 0.1 t. And if you're not sure about that, you can of course guess and check until you get the constants right. So we're going to be able to use this antiderivative plus the FTC again to evaluate our integral. So that tells me that f of t is 100 plus my antiderivative evaluated at both of the endpoints of the integral. So that formula looks like this. And simplifying, I find that f of t is 200 over 1 plus e to the minus 0.1 t. So the problem asked me to find when is the population of beetles equal to 1,000. And so now I can just solve f of t equals 1,000 for t and find out that time. So solving that equation, I get that the natural log of 4 over 5 equals minus 0.1 t. So in other words, t is equal to the natural log of 4 over 5 divided by minus 0.1, which is approximately equal to 2.23. All right, that's all for today. Have a nice day.